All right, today we're going to get into a field of biology called cytology. Now it's kind of within biology, but now we're just focusing on what kinds of things? Living things, but very little. All right, so this is kind of a realm of biology where we're only dealing with the smallest living things. Okay. Now, we can use this to look at bigger things, but for the most part, we're going to be focusing on things that are really small, the size of cells. So when you look at this word, cyto means cell. What's ology?
Study of.
Study of. So, I mean, that pretty much tells you what we're going to be doing. We're studying cells. Okay, now we're working from a chemistry level, glucose and lipids and proteins, and we put enough of those things together and we build things that are bigger called cells. And that's about where we're at as far as how things are building kind of in sequence. All right. So today, really want to focus on two things. And this is what you guys just read a little bit about. Each group focused on a little different aspect. The first group was focusing more on the history. The second group was talking more about size, okay, measuring. How do we measure in a small realm? Third group was focused on what an electron microscope, how it's different. And then this fourth group was actually looking at different kinds of electron microscopes. So there's a couple different aspects we'll hit today, and some aspects we'll probably hit a little bit more next time. All right, so how did we discover cells? We're going to talk about two individuals that the first group is going to tell us a little bit about. And then how did we even get to know that this world even existed? Like the Horton Hears a Who thing, half of us wouldn't even have any idea if we didn't know that someone had discovered it for us.
Wait, so it is real?
It is.
Is it really?
All right. What?
Like,
Horton Hears a
if
Who?
we-
No.
If we
Like,
did
legitimately,
it
like,
on
on
the
a
rest of the last
little
speck,
Imagine
that.
Just, I mean, yeah, I mean, that's what can, it really can blow your mind. When you think the tiniest possible speck, let's say a grain of sand.
Like we live on that.
I mean, just that infinitesimally small thing
Oh,
is
it
going to
is.
have billions, trillions of microscopic things all over it, whether it's viruses or bacteria or...
Yeah, what if we did live on something bigger?
I mean, I don't know, did you guys ever watch the Men in Black series?
Yes.
Where they open up the locker and... You guys know what I'm talking about?
Davy Jones
Okay. No, that's different. All right, but they open up that locker and... Same idea. Okay, it's the same idea where we're thinking, whoa, what if we're on a little speck? Okay, anyway. Okay, so let's start with some history. I'm not a huge history person because it's always looking backwards. Okay, but
I'm sick of looking back.
It-
I want to live in present day.
I agree, Austin. All right, so we've got to know where we've been to really know where we're going. That's really the only part of history that I really care for. All right, so we've got to look at some people who made some big contributions to kind of get us to where we are now. And the first one was, you don't have to write word for word, guys. You're not writing word for word, are you really?
Yes.
Yeah.
Really?
Yeah.
Okay, you can get past that idea. All
Well,
right,
don't
my
you
word.
forget-
You're saying my words are that important?
Yes.
Okay.
Yeah. I'd rather get
That's
all
flattering.
of it.
That's
I'd
flattering.
rather get everything.
That's flattering, but you could have just summarized this: people who made contributions.
Well, we don't want to do that. You're going to take it like that.
Okay.
You're gonna test it like that, so we're gonna write it down.
Okay. Well, I would encourage you not to write everything.
That's how I do
I take
it.
notes so I don't remember.
Because I'm going to go way too fast. You're not going to be able to keep up with me.
Great.
Yeah, well.
You can look at it like, all right. The first person. So this is under history. I kind of used an outline format, but
Robert Hooke.
Robert Hooke. No, he wasn't a captain. Let's take care of that.
Was he a chief?
Let me tell a little bit about him, Austin.
Oh,
Okay. Some details the first group got for us. This is back in the 1600s.
Can you move?
Gosh. 1600s in England. A lot of this stuff is going to be happening there. Why aren't any of these discoveries going to be in America?
Because it's
Because we're
England.
dumb.
Think about it.
We didn't come
didn't
over
know
to
it was
America.
We didn't exist yet. Okay, so think in terms of history. This is 1600s. Okay, has really nothing to do with our intelligence level. It's just we didn't exist yet. Okay.
Austin, you get the chair back.
All right.
Draw his face.
Alright, I hate that.
Reason we're talking about this guy. Thank you. The reason we're talking about this guy, the biggest contribution he made toward this field was he developed the tool. Okay, the world of the microscope, the microscopic universe didn't exist because we couldn't see it. So really this was the biggest advancement in this time period. Was it opened up a whole other dimension. Okay, not the distant world. We had telescopes. Galileo and Newton and all these big thinkers had looked at the stars and the planets hundreds of years before. But now we are seeing this very, very, very small. So that's probably the first big thing. The next big thing he did was he added lenses. Lenses are what do the magnifying. Okay, before him, he had what were called simple microscopes. What's the difference? Simple versus compound.
Simple, you get more accomplished.
Okay, you can you can see smaller.
It's like an
Details, more
HD.
details.
Okay, we'll get to that in a second. Good job. All right, so a simple microscope was basically like a telescope. Had one lens, but the lens was oriented in a way that you could magnify, basically like that hand lens or magnifying glass. It can magnify it to a certain point, but by adding an additional lens, you get additional magnification. Okay? And he added a light. Now think about this. What kind of light might it have been? 1600s.
An LED light.
Sunlight.
Not
Candle.
sunlight. Is a flame.
Well,
Okay, so candle, a lamp. Okay, but we didn't have electricity. And this opened up, this seems really simple, but now we can work at night. Alright, now that again, seems basic, but those were a couple big advances. Third thing we credit to this guy. So he built the compound microscope, he added these lenses and a light, and he coined the phrase cell. Now obviously people had used this word before him, but he's credited for using it in reference to a part of a living thing. What's the story behind it, guys? Group A. Why did he call them cells? What was he looking at, first of all?
They look like forms or something like that the monks used to see.
Yeah. What was he looking at, though?
I was looking at that small cut cord.
Yeah, he took a piece of cork. Where does cork come from, by the way?
Wood.
Correct. So it would come from. Where does wood come from?
Tree.
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 Okay. This is actually this is from the inner part of a tree. Somebody in the other class had a wine bottle. No, that's not where cork comes from. Okay. We can use cork for a whole bunch of
Did
different
you
things,
drink your
but
wine bottle and get that off of it?
cork is basically part of a tree, so it is made of cells. It's dead cells, but it's still cells. And so when he took a sliver of this and put it under his microscope, he saw these boxes,
Oh, yeah.
all right, which reminded him of monastery cells where monks would live.
Oh.
This rectangular room, he called it a cell.
Was he a monk?
All right?
I thought
He
it was
wasn't.
something like jail.
He wasn't.
I
It
was.
was like jail.
Hey, I was trying to tell us things.
All right, so
It's close.
you don't have to sketch this, but just look at it critically.
Oh, I'm
This is his microscope.
like a fish hook.
This is his
So
microscope.
complicated.
Okay, couple basic parts.
Quite complicated.
Here's the first lens, called an eyepiece, obviously because
So we keep our eye-
that's where you put your eye. Okay, so we're gonna put our eyeball there.
Focus.
There's this barrel that's just air, okay, it's filled with just empty space. There's a ability to focus, which is gonna bring us closer or farther from the object. And then your second lens is called the objective, and you could switch that out depending on how much magnification you wanted. So that's why it's a compound microscope. Specimen goes here on a little holder, and here's your light, which is an oil lamp and a water flask. Now, why this? What would be the purpose of that? That's not a bad idea, Nicole. It reflects it.
Refract.
Okay, refracts it. All right, so what does that mean? What does refract mean?
Just
I don't know, you put a pencil in water and you look at it, it's like not lined up. with
Yeah.
itself.
All right, refract means to
Yeah.
bend. Okay. So when the light goes through that, here's your flickering flame. When that light passes through that sphere of water, it actually focuses it on the specimen. Now, it's like taking a flashlight before flashlights. Okay, so we took a flashlight and we're putting it right on that because you can't see it without sufficient light. So the more light that bounces off into the microscope, the better. Okay? Now, what did he actually see? This is his sketch. So if you were to look at cork, you would see something that looks like that. Do you see the cells?
No,
Yeah.
it's not like a
All right, now Jesse, this is where I'm curious. Why does this look different than this? These look rectangular, and these don't.
Why is it sideways?
It's sideways. In case you could tell. All right, so this one is cut this way. So you're looking at the side view. This is looking from the top down, and so it doesn't. You see little channels that are actually circular.
Yeah.
They're not square. Okay.
And then like, okay.
All right, let's take a look at number 2 guy.
What did you say?
Anton von Leeuwenhoek, I think.
Leeuwenhoek.
Leeuwenhoek. Maybe a Leeuwenhoek. Anton von Leeuwenhoek. Okay.
It's a long name.
Couple things about him. From the Netherlands. So this is pretty close to England, same general area, Europe. 10 years later. Okay, so kind of the same local vicinity. As far as I know, these guys didn't know each other.
but they did it.
He did something different. Not compound, that was Robert Hooke. He was working with simple microscopes.
Excuse me.
I know he
Every single time. Every single
Like he'll
time.
move this way and I'll look this way, and he'll step, and then
So he's working with simple microscopes, only one lens, but he's making the lenses very, very good. Fine resolution. So he's focusing not on the number of lenses, but how good the lenses are, the quality. And he was known to be one of the best lens crafters in the day.
That's
Okay.
1675.
1675. Okay, realizing they don't have the technology that we do now.
Yeah.
So to craft these very smooth, small lenses
Yeah, that'd be nice.
was painstaking.
Who gets up one morning and just says, hey, let's do this?
Hey, let's do this. Well, I mean, this wasn't the only thing they were doing, but the story behind him is a little bit more interesting. Now, he's credited for finding something in water.
Oh.
Okay.
Was it
Now,
fish?
most of us, if you've, I'm hoping you have swum, swam. You've swum in a lake, or a river, or a pond at some point in your life. All right, now, chances are that water wasn't clean.
Mommy says I can't swim.
It's not like safe, but.
In other words, the water, fresh water is not pool water.
No, pool water's not the.
Pool water has been chemically treated to kill
And it hurts.
living things in it, usually with chlorine.
Yes.
Chlorine is toxic to living things.
I drink.
Okay, so that's why you don't want to have too high or too low of that concentration.
Like our
All right.
drinking fountains, put water in a water bottle. for a
Sometimes
day,
it
so
can,
like-
yeah, sometimes it can be really strong, okay?
Yeah.
Now,
It's nasty.
the cool thing was, he was looking at pond water under his microscope, and in that time frame, you would think water was clean. So if you're drinking water from the river,
Ew.
you didn't know.
Someone could have been peeing.
You don't know
Fishy.
that there was stuff in there
Ew.
that would really bother you.
Yeah.
We now know, obviously, untreated water can make you sick.
Yeah.
There's a lot of living things in there.
Is that why they made beer?
He discovered things moving around in the water called animalcules.
Ew.
He called them animalcules. It's
Wait,
just
what'd you
literally,
say?
animalcules literally means little animal. I'll show you what he saw in a little bit. Okay. Now, I don't know what the reaction was, but personally, if I thought my water was clean, and then I looked at it under a microscope and saw all these sorts of things living
I went drinking.
and moving around very quickly under it,
I'd
I
probably
would
puke it.
probably start to question whether I should be drinking that water. Okay? All right, so let's see what this stuff,
Oh, dang, I thought we were peeing.
let's see what this stuff looked like. Well, I'm gonna show you. Maybe.
Alright, let's go.
Maybe.
Are we gonna have to know these guys? Like,
Robert Hook? Let me know.
are we gonna have to know them?
Should.
I'm gonna call Robert.
There's only two.
There's no Brad stuff. We'll put Brad's
two right now.
on this. For now.
Yeah. But you have to know dates and stuff and history of that.
You won't put Brad's name on the papers.
1665 and 1670.
Really?
It's not that complicated.
Yeah. it
2
is.
dates. All right, let's take a look at some of these guys.
For now, 2 days. You said for now.
For now.
Do you want me to put Brad's name on this?
What's that?
Yeah.
You just put Brad taking tests.
Okay.
All right, ready to see some of these things? I think they're kind of cool.
This is important.
Now, eventually you're going to see some of these same things, but not today.
This is what you're swimming in.
Yeah, this is what you're swimming in. I don't know.
What is that?
Oh.
That makes me never want to swim in a pond again.
Oh, wow.
I want to put calcium in a pool or in a lake.
That's a cool one. That's an amoeba.
Do you know what it can do?
What does it do?
I swim in
What do they
the
do?
pool.
Does it touch us?
Oh yeah.
Yeah, you touch it.
No, they swim
They'd be all over you.
Mr. Croy.
All over you. And the cool thing is if you drink some of the
Even
water.
when you shower?
Oh, well, no. I mean, that's all treated water, but I mean, if you're in a pond or a lake
Does it come
or
off when you shower?
a river or something.
Yeah, does
What
it
if you have
come
well
off
water?
when you shower?
Well water is filtered through the ground, so it's pretty sanitary too.
God,
Yeah.
I'm very ill.
Whether you get municipal water or well water, it wouldn't have these things in it.
But when you shower, does like stuff come off?
What?
Does
Oh,
it-
after you would swim in a pond or something, yeah, they'd wash it off.
No, it stays on.
It's in your finger.
Unless you had a cut or something. I mean, if it had a way of getting into your body, it's possible.
What? Does peroxide kill that stuff? Dang it! Peroxide, my body.
Now, I mean, this is very much what Lewin Hope would have seen.
This is
That's
disgusting.
nasty though.
He would have seen these things living in one droplet of water.
Ew. I'm planning it.
Water in there.
There's Mr. Brian.
Yes.
This peroxide kill this stuff.
Yeah. Peroxide doesn't.
I chew on my fingers. I have cuts on
Let's
my.
swim in peroxide.
Now, I mean, these are only found in fresh water.
Well, like, cause I
So-
get cut. I like salt water.
We wouldn't find these in salt water. There'd be different ones. These are-
Like there'd be different ones.
These are only fresh water.
We see what's in salt water.
Creeks, streams.
Can we see what's in salt water?
Oh my god.
If we have time, I'll see if I can find some.
I left some puke in there last year.
Now, we'll actually,
I saw
these are called vorticella.
Ew.
If you notice, they have little hairs, little called cilia, that help to bring food into their body. Isn't that cool?
Yeah, I heard about that.
When I was there, I was
like,
like, dude, I was about to like break his head into some freaking like the stone thing.
Make it a little bit smaller, that way it'll load. We'll just watch a little bit of it. I'm not going to show you the whole thing.
He goes, oh my god, snake.
Oh, don't
He's
say
like,
one.
"Well, okay, let's put it back. I'm like, yes, we're swimming in here.
Put it back.
Now, because this one's green,
It's dirty.
now what do you think it has the ability to do?
Eat
That
you.
was all.
It's green.
Get rid of
Make its own food.
Make its own food. So this is kind of like a precursor to a plant.
But you can never get
But it's not a plant.
Does
But
it eat your skin?
it can do photosynthesis. It has chlorophyll inside of it.
Do they eat dead skin off your body?
Well, most of this stuff is eating things that are smaller than it. So like those are some sort of paramecium.
What was like purple?
They're actually a predator.
What do they do? Like, I bet we're.
They eat things that are smaller than it.
Am I smaller than it?
Okay. So, why do they get on our bodies?
Well, because they're in the water, and the water's on your body.
That's disgusting.
But you would have no way of ever knowing they were there.
Now I do.
Now you do, but it's like, oh, I mean, you wouldn't even be able to feel them. They're too small. You wouldn't even be able to feel them.
I think I'm gonna stick with my back wire. Dude, Mr. Bryant.
Okay.
You know when you get that feeling that something's crawling on you in the water?
Now you know what it is. Yeah. Well, but you wouldn't know.
I think I'm gonna go swimming in my bathtub.
All right, lights. Ready?
I'll make it flat.
Okay. All right. So if nothing else, you've got a better idea of what he would have seen. I mean, just imagine how blown away you were. If you were in his shoes and you saw it, well, this water's clean, and then you go out and tell everybody what you saw. What do they think of you?
You're crazy.
You're a crazy man. You have no idea what you're talking about. Okay, go back to your crazy world microscope. Well, let's look at his microscope. This is really going to floor you.
Where are you?
What the heck?
How
was that cute?
How
That's
pretty.
neat.
It looks like a little paddle boat.
Look at how small that
It looks
is.
like a good
I would love to see you trying.
It looks like a piece of metal.
I mean, all right. So there's human hand. This thing is probably only about an inch and a half big.
How are you supposed to look through that?
Okay, maybe about 6 centimeters or so.
He must have had 20/20 vision.
Now, here's what's weird. Where is the lens?
The thing is the lens.
Not the whole thing.
It's that little hole right there. That one.
No, it's not.
Okay. All right, so this is how it would work. You're looking at the back of it, actually.
Oh, that's where
The front is the other side. Think of a hotel peephole. Okay, just that little mirror, that little lens that you look through at the door. And the other side looks big.
Yeah.
Yeah.
This is the same idea.
Oh.
Okay, so what he would do is he'd put, I mean, it's almost impossible to show you, but a little drop of water on that point. It'd actually stick to the metal a little bit. He'd turn it around and put that lens right
his
next
eye?
to his eye and
What
would
if it
look
dropped in
through that
He'd
lens.
freak out. I'd freak out.
Okay? Now, this is nowhere sophisticated as hooks, but he would actually be able to get magnifications of up to 400, which is what we can do with our microscopes with 2 lenses. He could do with his one really good lens.
How'd you
So-
make that?
Pretty amazing little contraption. There's only a few of those that still exist.
How did he make
In the
it?
I made one.
How did he make the lens?
Yeah.
I was hoping nobody would ask. Jeff.
Too bad.
Because I didn't bring the stuff. I promise I'll bring the stuff on Thursday. I'll show you how he did it.
I'll remind you of
Okay.
that.
Make it look
Make a
good.
note.
Nah, make a note.
I will.
In case you want to make a note. But it requires some fire and some glass.
Yeah.
So usually I would have brought it, but I forgot this morning. But I need a hot enough fire to melt the glass.
Has fire.
Well, but it's not hot enough. I need a propane torch. Or natural torch. I gotta get it hot
Oh, I
enough.
ever seen the lighters that torch?
They didn't have
The
propane
lighters
torches back
that
then.
torch and it has like different colors.
Oh, yeah.
The torch ones.
They didn't have propane
Okay.
torches back then.
So today, we're gonna go over some parts of the microscope. We'll see what you guys know and see what you get. We got just a few minutes here.